Okay, so now this GeoGebra, okay, what we have done here is,
Sir.
so basically this is a vector x, okay,
Okay, sir.
and this is the vector b,
Okay.
okay, the output. This is an input, this is an
Oh,
output, okay. So this input is multiplied with by a matrix A, where the A is the first component is A,
two,
1 1 is 2, 2 1 is 1, 1 2 is 1,
one.
and 2 2 is 2. Okay, this thing we can edit. Okay,
Yes.
now for a given input, what is the output is what this point P2 will give. Okay, so now if you drag these points, accordingly the output will also
Change.
get changed. Okay,
Okay. Yes.
so now tell me, if I drag this point to 0 comma 1,
Okay, sir.
so where will be the P2? Just once again look at this one and tell me.
2 ones.
The x is
0, 1, 0.
when I drag this to 1 comma 0.
Yes.
Okay, where will this point go?
2 ones.
2 comma 1.
2,
So let's check. So yeah, we have got 2 comma 1. Okay, so because that's going to be
First
the
column.
first column, and similarly the second column, if you drag this point
0,
and put it over there,
yes.
you will get
1,
1 comma 2.
Yes.
Okay, fine. Now say for example, so with this one, what else you could do is, say for a given input, okay,
Okay,
sorry, for a given output, let's see whether you could calculate the input um, just by dragging this point. Okay, so what I want you to do is, the P2 has to be, I mean, if P2 has to be 1 comma 1,
1, 1. Okay, sir.
what should be P1? Okay, maybe you may have, for this case, you may have to use some methods like, yeah, but what I want you to do is, I want you to click and drag that point P1 so that P2 will reach approximately to 1 comma 1. Yeah, okay.
Yes.
So the point, I think you can read that point over here, right? So which is 0.3 or 1 by 3 comma 1 by 3
3.
around. Okay, fine. Now if you notice here, the direction of point P1 and P2 are same. Right?
Yes, sir.
And if you notice, if you drag this point, the input point along this line, okay, you will always have the P2 is also along that one. Okay, and it is same, either it's in the positive direction or negative direction. Okay,
Yes, sir.
so what do you call this? So but you will not have, maybe you will have another yeah, so you will have another vector like this,
Okay,
which will have the same direction. Okay, what do you call this kind of special, and nowhere you will see such a those two things having the same direction. What do you call such a directions, or such a special vectors among all those vectors?
No idea.
Sorry?
No ideas.
Okay, so those special vectors where the input vector is same as the output, I mean the direction of the input vector is same as the direction of the output vector, then those vectors are called eigenvectors. Okay, so this is what eigenvector. So it will have the same direction. Okay, the input as well as the output.
Okay, sir.
And for a 2 by 2 matrix, you will have
Two.
two eigenvectors. So one eigenvector is kind of either 1 comma 1 or some multiplication of 1 comma 1, and another eigenvector is 1 comma
Negative.
minus 1 or minus 1 comma 1, whatever. Okay, so that's the another eigenvector. Okay, so now what I want you to do is you know how to calculate eigenvalues and eigenvector.
Yes.
So note this matrix 2 1 1 2. Okay, now with whatever the method you know, try to calculate the eigenvector as well as the eigenvalues. Okay.